Hello class, this is section 4.1 sample space and probability. So we are working on the probability for this chapter 4. So probability is the chance, it's a chance as an event occurs. So probability is based on the inferential statistic, and probability experiment, chance process that leads to well-defined results called the outcomes. Outcome is a result of the single trial, is a probability experiment. Trial means the flipping a coin. So this is kind of example, flipping a coin, rolling one die once, and answering the multiple choice questions without 4 options by selection. When tossing a coin, and there'll be 2 outcomes, which is a head and tail. And then the multiple choices question as an example, you might have a choice of A, B, C, D. Okay, so sample space. The set of all possible outcomes is a probability experiment. So experiment, I'm gonna be toss one coin, roll a die, and answer all true/false questions, and toss 2 coins. So toss one coin, you might have a head and tail, and rolling a die, you have a 1, 2, 3, 4, 5, 6, but because there are 6 sides. Answering a true/false question, it could be a true or false. But if you have a tossing 2 coins, the chance are the head and head, tail, tail, head, tail, or tail, head. So this simple spaces has been found by the observation and reasoning. Charts and tree diagram help to organize the possible outcomes. So example 1, we are using the charts to find out all the outcomes as a sample space. So find the sample space rolling 2 standard 6 side dice. So if you, let's say this is die 1, and let's say this is die 2. So if you have a die 1 has might be 1, and the other one is 1, and then 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. So first die show 1, second die show 1, first die show 1, second die show 2. Okay, so and then it could be 2 and 1, 2, 2, 2, 3, 2, 4, 2, 6, 2, 5, and 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So when you count them, there'll be 36 outcomes in sample space. If you're using the two dice. Okay, let's go to the next problem. Now, in the next problem, I'm going to use the tree diagram. That's actually easier to we can think about it. So find the sample space for the gender of the 3 children this time. So in a family have 3 children, find the sample space for the birth order by gender of the children. So I'm using the tree diagram. So first child could be as a parent, from the parents, it could be a boy or girl. As a first child. As a second child, it could be a boy or a girl. But what if you have a first child as a girl? Also, it could be a boy or a girl for the as a second child. And then third child, it could be another boy, it could be another girl, it could be a girl. From the girl, it could be a boy or a girl. It could be a boy or girl. It could be a boy or girl. So, as a sample space, that's it. In the sample space as outcomes, it's gonna be the boy, 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 girl. It could be boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and then girl, girl, girl. So there'll be a 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 outcomes in a sample space. All right, let's talk about event. Event is the set of the outcomes of the probability experiment. So events can be the one outcome or more than the one outcome. An event with exactly one outcome is called a simple event. And the event with a more than one outcome is called a compound event. So we're going to talk about 3 interpretations of the probability. So the classical probability use a sample space to determine the numerical probability that has an event will happen. Classical probability assume that all outcomes in the sample space are equally likely to occur. So everything is kind of fair. Okay, so not is the leading to the one of the outcomes. If the sample space has n equal likely outcomes and event A has a k outcomes, then the classical probability of the event A has as a probability is going to be number of the outcome in A over number of the outcomes in the sample space, which is a k over n. So find the probability, refer to the example 2. What is the probability that all three children are the same gender? So probability for all 3 has same gender, which is there are 8 outcomes, but the event is all 3 must be the same gender, which is there'll be a boy, 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 and girl, 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 right? So there'll be a 2, so which is a 1/4, because there's a boy, 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 and girl, girl, girl. Okay, so there'll be a 2 out of 8, which is a 1/4. Okay, let's look at the next problem. The probability rules. There are 4 characteristics of the probabilities. We use them to solve the probability problems. Understanding the nature of the probability and deciding whether the answer to the probability problems are correct. So probability must be between the 0 to 1. So it can be less than 0 or more than 1. So always between the 0 to 1 because it comes with a fraction or decimal. The sum of the probability outcome is always equal to 1. So this is very important here. So if you're adding all the probability together, must be equal to 1. If an event A cannot occur, that is a sample space empty, event is impossible, in that case, we call the P of A is equal to 0. But if the event is the must come out true always, certain, and then we always say P of A equal to 1. Okay, so let's look at the number 4. Probability of the rolling 1 die. Consider the rolling 1 standard fair die. Find the probability of the rolling 1. So when you have a 1 die, there's a sample space as 1, 2, 3, 4, 5, and 6. Let me change the color. So I'm looking for the probability that is you getting a 5. So 5 is a 1 of them, right? But it's going to be 1 out of 6. Now, if you're looking for find the probability that the rolling a multiple of 3. So multiple of the 3, you got 3 and 6. So probability to get rolling a multiple of 3 will be, there'll be a 2 number out of 6, which is you can say 1/3. Find the probability of rolling 8, which is, I don't see 8 in the sample space, which means the rolling on 8 is 0 out of 6, which is a 0. This is not possible. What about the finding a certain probability? Find the probability for the certain event, which means find the probability of rolling value that less than 7. So any value less than 7, which is 1, 2, 3, 4, 5, and 6, which is P of the rolling a value less than 7 is out of 6, there are 6 of them, so it'll be a 1. Complement events. Complement events A is the set of the outcome in the sample space that are not included in the outcomes of event A, denoted A bar. Find the complement of the event. Find the complement of the event. So event A is select the day of the week that begin with a T, which means we know that there's about Tuesday and Thursday of the week. So if you want to write down the complement of the event, which is I want to say A bar, which is going to be that we are select a day of the week that does not begin with T, which means that we are set Sunday, Monday, Wednesday, Friday, and Saturday. All right, rolling B. Event B. Roll 2 die and I get a sum that is an odd number. That is a sum of the 3, 5, 7, 9 or 11. So as a B bar, okay, we roll 2 die and get a sum that is not enough. Which makes the sum of 2, 4, 6, 8, 10, or 12. So that's a B bar. So in order to get a probability of the B A bar, always subtract from the 1 to the probability of the A. Or other way too. Or if you're adding the probability of the A and the probability of the complement of the A, always equal to 1. So we are talking about empirical rule. Empirical probability rely on the actual experience or observation to determine the likelihood, the relative frequency of the outcomes. So probability is actually, this is a probability rule. So we talk about that in the previous chapters, okay? All right, it's a symmetrical. Let's go to the next page. Okay, given a frequency distribution, empirical probability of the event being in a given class is probability A is a frequency for the class of the interest, which is F, and total frequencies in the distribution equal to N. So number 8, we're using the empirical rules to find the blood type. Okay, so this is actually we can think is the empirical rules, empirical probability. So survey of the blood type of the 50 people. So these are totals of 50. So there are total 50. Okay, so total is a 50. And then you build that. And then 20 had a type O. And then 22 had type A. 5 people got a type B. And then 2 got the type AB blood. So using the frequency table, we can find the empirical probability. So we are looking for the person that has O blood, which is there are 50 people and 21 people do that. Okay, so which is about 0.42. The next one, we're looking for the probability that type A, which is 22, And then type AB, which is a 2 out of the 50, which makes a 24 out of 50, reduced as a 12 over 25, as a decimal 0.48. A person who had neither A nor AB. So, which means I'm gonna use the event for the B. So in this case, I'm gonna use the 1 minus of the probability that we have. A person had type A or AB blood, which is 1 minus 12 over 25, which equal to 0.52. Or you can just use the because it's neither A, which is the B, right? 5 over or you can just say type B, which is a 5 over 50, and plus O, 21 over 50, which is what 26 over 50, which is going to be a 13 over 25. Okay, so it's going to be the same. Either way is fine, but you can just use the complement to find the probability too. So empirical probability have a same value as the relative frequencies of the outcomes in the distribution. So next button. So this is always happens if you see this, okay? So law of the larger numbers, larger number. So law of the larger number states that as the number trial of the random experiment increases, so try more and more and more. Trial. Okay, I need to actually, come on. I think it's a freeze. All right, so I'm going to do this. All right, so law of the larger number. So if the number of the trial is going to be increases, the empirical probability will approach the classical or theoretical probability. Suppose the fair die is tossed. The classical probability for each value from the 1 to 6 is 1 over 6. For the real experiment using a fair die, number tossed that result in the 2 increases and the empirical probability of the tossing 2 will approach theoretical probability of the 1/6. If a die is tossed many times, as the empirical probability of the tossing 2 is not approaching the 1/6, but then likely the die is not fair. Subject probability. Subject probability is based on the educated guess or estimate opinion and exact information. The probability is based on the person's experience and evaluation of the solution. So for instance, weather forecaster predicts up to 65% chance of the rain, or a sport writer may say that there is a 70% chance to a particular team will win the pennant that the year, are examples of the use of the subjective probability because that's their opinion, or that's the educated guess because they're the professional on the job. Okay, all right. Thank you for listening.